0.6. Now we're going to look at double angles. So here we can go ahead and we can't divide by 2 here because these 2's won't cancel and those don't equal each other because this is taking 2 times our angle and then taking cosine. So I actually can't do that. But I can use my identity here for double angle of cosine, and I probably want to use the one with cosine in because this is equal to cosine. So I switch this to the identity, which is, let's see, 2 cosine squared x minus 1. That equals cosine x. Then I can bring this over and get 2 cosine squared x minus cosine x minus 1 equals 0, so I set it equal to 0. Then I have a quadratic, so I factor this. Right, instead of that looking like a quadratic, I can cab it. So CA is -2, and my B is -1, so that's a -2 times a +1, because -2 plus 1 equals -1. So U minus 2 and U plus 1 equals 0, so that means I'm multiplying 2 things and the answer is 0, so that means one of those things equals 0 or both of those things equals 0. Solve for U. +2, U is -1. Now I can substitute U back in, which is cosine x. So where's cosine x2? And where's cosine x -1? But you need to make sure that you always divide by your a, right? Because I have an a here, so I need to divide these by 2. So that'd be divided by 2, that'd be divided by 2. So this is really divided by 2. So actually I'm looking for at what angle, cosine of what angle is 1, and cosine of what angle is -1/2. So -1/2 would be, so cosine is negative in the second and third quadrant, so that'd be at 120 degrees, and at 240 degrees. Unless if I'm doing radians, then that's 2 pi thirds and a 4 pi thirds, which I think I am. Yeah. So in radians, and then where's cosine 1 at? That is at 0, correct? And so at 0 degrees or 0 radians, right? So there's my answers for x's, all 3 of those. Okay, using solving with multiple angles, kind of same thing here. I can use an identity. So I could switch these. So I could switch, I could switch sine for cosine, right? I could substitute in the square root of 1 minus cosine squared x, but then I would have to square both sides eventually, so might as well not do that. But what this kind of looks like is I know that 2 times sine of theta times cosine of theta is equal to the double angle of sine of 2 times an angle, right? So that is true, but this is a 4 here, so how could I switch that to a 2? Well, if I divide both sides by 2, then I would get this 2 times sine of theta cosine of theta equals √3 over 2. And now, so I can substitute this, right, this, for sine of 2 theta. So sine of 2 theta equals √3 over 2. Now I can ask myself, okay, what is the angle of sine that gives me a √3 over 2, a positive √3 over 2? So that would be in the first and second quadrant, and that is a 60-degree angle, so pi thirds, and 2 pi thirds. If I'm from, so 60 or 120, it doesn't really say which one here. Okay, so that is 2 times theta, right? So our answers, say, are between, since I'm doing radians, we'd say 0 between 2 pi, right? That's where our answers of theta would be, but here we have 2 times theta, so I would times both of these by 2. So basically, I guess you could write it more like this. 0 theta is between 0 and 2 pi. So if I have 2 theta, this would be times by 2 would still be 0, and times by 2 here. So I'd get 0, and I actually get 4 pi. So I'm going to actually look around 4 pi. So if I add 2 pi to each one of these, then I would have all 4 of my answers. So that would be plus 2 pi. So if I'm adding 2 pi to this, that would be a 6 pi over 3 with a common denominator, right? This would be 6 pi over 3, because 6 divided by 3 is 2, so I'd get 2 pi, right? So my other ones are 7 pi thirds and 8 pi thirds. So those are actually all four of my answers here. So 2 theta equals pi thirds, 2 pi thirds, because I'm going from 0 to 4 pi, or from 0 to 720 degrees. And then 7 pi thirds and an 8 pi thirds. And now if I divide by 2, because I want to get theta by itself, so I divide all those by 2, right? So theta is equal to, dividing by 2 is like times by 1/2, so that's pi sixth. So that's 2 pi sixth, which reduces down to pi thirds. This one is 7 pi sixth, so 7 pi sixth. And this is 8 pi sixth, which reduces down to, divided by 2 there, that's 4 pi thirds. So those are all your answers there for theta. So all four of those. Basically, whenever you have a double angle, however many answers you have, just double that, and that should have. So normally we have 2 answers, right? We double that, and we're going to have 4 answers. Okay, so here's 3 problems due on 697, number 75, 71, and 95. And here I'll do them real quick. So here we go, sine of x equals sine of 2x. And I guess when it's x, you want to do in radians. Yeah, in radians. So we want our answers in radians from 0 to 2 pi. So here we're going to switch this to kind of like our example, to sine of x cosine of x. Okay, and then I can subtract this over, and I get 0 equals 2 sine of x cosine of x minus sine of x. And I can factor out a sine. So 2 sine x times by cosine of x. Actually, that 2 stays in there. So I'm only factoring out a sine of x. So that 2 stays in there. Minus 1. And so that equals, right? This right here, no, that's not squared, so that's fine. So there we go. So now we're multiplying, right? 2 terms. So I can set, since our answer is 0, I can set them both equals 0. And then solve for the trig function. So sine of x still says sine of x equals 0. This one, I'm going to add 1 to both sides, and then go ahead and divide by 2. So where's sine 0 at? Sine is 0 at 0 radians and at pi radians. And then for this one, my x is equal to, where's cosine 1/2? So where's cosine 1/2? A positive 1/2. That would be at 60 degrees, so that's pi thirds. And then down, so at 3, down 60 degrees, so that's at 300, and 300 is just a pi thirds down, so 5 pi thirds. So those are my 4 answers. Okay, so here we're not going to substitute here, we're just going to get this double angle by itself, so divide by root 2. So dividing by root 2 is like multiplying by, it's reciprocal, 1 over root 2, which is root 2 over 2. So this becomes, or I can just rationalize this, right? So negative root 2 over 2. Now I can say, okay, where's cosine negative root 2 over 2? It's cosine, so it's a 45-degree angle. And because it's theta, we're doing degrees. So that's 45 degrees, and then down 45, so that's 315. And so that's a double angle, right? So then we're going to have to go double around. So instead of from 0 to 360, we're going to go from 0 to 720, because it's double our angle, right? So that's actually going to be 720. So we need to add 360 to these. So 360 plus this one is 685. 685 degrees. And then add, so that'd be 405. Am I doing my math right? 45 plus 360, yes, it's 405, and 300 is 600. 45 and, or 60 plus 15, yeah, oh, plus 15 is 175, or 75, all right, 300, yeah, okay, so there's the 4, right, and then we divide by 2, so theta equals 22.5 equals 157.5. Oh dang, I did the positives. So crap. Sorry about that. Let's erase these. I did the positives because I'm looking for negative root 2. So that's a 120 degrees. That's a so add 360 to that. So that would also include 360 is 480, and then also 240. Add 360, so that's at 300. That's 500. 540 plus 60 is 600 degrees. Okay, and so then we can go ahead and divide those by 2, so that's 60 degrees. Root 2 over 2. Third time's the charm. Okay, one more time. Root 2 over 2. Let's do root 2 over 2. Negative root 2 over 2. Okay, so my angle is, it's a 135. And then plus 360. Or let's just do and add 180. Another 45 is 215. And then add 360. 95 and 575 degrees. Okay, and then divide all those by 2. We get 67.5. We get 1, or this should be 225. So then we get 112.5, 247.5, and 292.5. Okay, so there we go. Third time's charm. Okay, number 95. Okay, so we want to get our sines of 2 theta by themselves. So if we add sine of 2 theta here, then we get 2 equals 5 sine of 2 theta. Divide by 5 on both sides. So sine of 2 theta is equal to 2/5. So this we're going to have to do on our calculator. So sine inverse of 2/5 equals 2 theta. So we're in degrees, so we go ahead and do that. And then we're going to have 2 theta. We're going to double all our answers, and then we're going to divide by 2. And so we should get these answers for number 95. 11.8 degrees and 78.2 degrees. And then we can go ahead and add and get our, because we have the doubles. So this is, so here our originals is 23.6 degrees and 156.4. Those balance around, this is just our reference angle, 23. So if we take 180 and subtract 23.6, that's where we get the 156. And if we go ahead and add 360 to those, we get 383.6 degrees. And then our last one is taking 156.4 and adding 360, and we get 516.4, and then we can divide those all by 2. So we get 258.2. 156.4 divided by 2 is 78.2, and 23.6 is 11.8, and then the 383.6 divided by 2 equals 1, that's degrees, 191.8 degrees. So those are all your answers.